Here's a look at problems 4 and 5 on the horizontal projectile motion review. Problem number 4, a rifle is aimed horizontally at a target that's 30 meters away, so that's going to be the x displacement. The bullet hits the target 1.9 centimeters or 0.019 meters below the actual aiming spot, so that's our displacement in the y direction. What are A, the bullet's time of flight, so we're looking for t, and B, the speed as it emerged from the rifle, which is the velocity in the x direction. So we're looking for v over here, and the time, and that can be found in either the x or the y. So we have to see, where do we have our numbers? We have the displacement in the x, that's 30 meters, how far away the target is. We have the displacement in the y direction, it went downward 0.019 meters, that's why it's negative. The initial velocity in the y direction is 0 because it was fired horizontally, and the acceleration is negative 9.8 meters per second squared. First thing we can find is the time, so we're going to use the third equation in the y direction because that's where we have three things. So d equals v naught t plus 1/2 at squared, but v naught is 0, so this term goes away, leaving us with d equals 1/2 at squared. Solving for time, I get the square root of 2d over a. That should just be t. That the reason the square root is here is to get rid of that squared. So you see, notice it's not down here. I plug in my numbers. Square root of 2 times negative 0.019 meters all over negative 9.8 meters per second squared gives me a time of 0.062 seconds. And it should be a very short period of time because we're talking about how long it takes a bullet to hit the target, and it's only about 30 meters away. Now we're going to find the velocity as it leaves the gun. D equals v times t, but if I rearrange that for velocity, velocity is distance or displacement over time. I have the displacement, 30 meters, I have the time, just solve for it, 0.062 seconds, and that gets me a velocity of 483.9 meters per second. Number 5. A baseball leaves a pitcher's hand horizontally at a speed of 161 kilometers per hour. The distance of the batter is 18.3 meters, so that's our displacement in the x direction on our picture here. A, how long does it take the ball to travel the first half of the distance? B, how long does it take to do the second half of the distance? C, how far does the ball fall during the first half? And D, how far does it fall during the second half? And finally E, why aren't the answers to C and D equal? Well, let's take them one at a time. A, how long does the ball take to travel the first half of the distance? Well, if the total displacement is 18.3 meters, then half of it is 9.15 meters. The velocity in the x direction is 44.7 meters per second. We had to convert 161 kilometers per hour. So I multiplied that by 1,000 meters per 1 kilometer and 1 hour per 3,600 seconds to get the velocity in the x direction of 44.7 meters per second. So I have the displacement in the x, that's half the displacement. I have the velocity, 44.7 meters per second, and I'm looking for time. How long does this take? I only have two numbers in the y direction, but that's okay because I'm only looking for time and I can get that in the x. D equals v times t for constant velocity. Rearranging for time, it's just the displacement over the velocity. 9.15 meters over 44.7 meters per second tells me it takes 0.2 seconds to go the first half of the trip. Part B, I set up my x and y stuff. The second half of the trip, the displacement's 9.15 meters. The velocity is still 44.7 meters per second, and I'm still looking for time. This is the exact same thing. Time is still displacement over velocity. It's the same displacement over the same velocity. So it takes the same amount of time to go halfway to the catcher as it does to go to the second half all the way to the catcher. Now we're going to move on to Part C. Part C said, how far does the ball fall during the first half of the trip? Well, the displacement is 9.15 meters. The velocity is 44.7 meters, and I know it takes 0.2 seconds. In the y direction, D, how far this thing falls, is the question mark. The initial velocity is 0, acceleration negative 9.8 meters per second squared, and we just solve for the time. It takes 0.2 seconds to go the first half of the trip. I'm going to use the third kinematics equation since I do not have VF. V naught is 0, so this term goes away. So D equals 1/2 a t squared. Plugging in my numbers, I get that the ball is going to fall 0.2 meters. Now D, how far is this thing going to fall for the second half of the trip? This one's a little bit more complicated. The way I chose to do it was to solve for the total time that it takes the ball to get to the catcher, which is 0.41 seconds. And I'm going to use that to find the total amount that is going to drop. Now you might say, well, isn't it the exact same thing as C? And it's actually not, because your initial velocity is not 0. if you try and go just from the halfway point to the catcher, because it is moving downward at this point. It's already started to go down, so it does have some y velocity. It's got some negative velocity right here, so I don't know what the initial velocity is for the second half of the trip. But I do know what it is if I do the whole trip. I know the whole displacement is 0.41 seconds. The initial velocity is 0. The acceleration is negative 9.8 meters per second squared. So with that information, I can solve for displacement because I have v naught, I have a, I have t. I'm going to use the third equation. Again, v naught is 0. And I can do d equals 1/2 at squared. Plug in my numbers, and I find that the total amount that the ball drops is 0.82 meters, or negative 0.82 meters. Well, now to figure out how far it falls for the second half, well, I take the total, 0.82 meters. I subtract how far it fell during the first half, which is 0.2 meters, and that gives me how far it must have fallen just during the second half, and that's 0.62 meters. You might be saying, well, why didn't it fall the exact same amount on both sides? And that's actually part E of this question. And the issue is that the ball is accelerating downward, so it covers more and more and more distance falling in the vertical direction every bit that it goes. Because it's accelerating, it's getting faster and faster and faster downward, so it's covering more and more and more distance every second.